want to discuss calculus, the differential calculus, one of the topics in Form 4. And mostly in this topic, we are going to deal with the equations of curves. We are going to deal with equations of curves. First of all, in this topic, we must know how to differentiate a function. How to differentiate a function. We have to know how to differentiate a function. Now, to differentiate, the rule that we follow to differentiate a function is that when you have a function x which is raised to power n, when this function is differentiated, we will take the power which is n, we pre-multiply with the x, then this power here is subtracted 1. Now, when the function is differentiated like x raised to power n, we get nx raised to power n minus 1. Now, for example, if you have a equation that you differentiate, you are told to differentiate the following equation: y is equal to 8x raised to power 5. To differentiate this, we follow this rule here. When we follow that rule there, we find that this power here pre-multiplies the coefficients of x. We find that this is 5 times 8, then x, then this one here we will reduce 5 raised to minus 1. Now we find that that is 40x raised to power 4. Now this equation is differentiated. Then another example, we can be told to differentiate y is equal to negative 4x raised to power 6. What do? We pre-multiply the coefficient with the power, that is 6 into negative 4x, then the power we subtract 1, that is 6 minus 1, that is negative 24x raised to power 5. Now that one is differentiated. The last example we can look at is y is equal to half x raised to power 4. Now the rule, that is this one multiplies this, that is 4 multiplied by a half, then this one is x raised to power 4 minus 1. What is that? That is 2x raised to power 3. Now that is how we differentiate. That is how we differentiate the equation. Now the thing that we have to discuss here, the next part that we are going to discuss here is the gradient. No, what to know here, the differentiated function can be called the derivative. It can be called the derivative. It is the same as the derivative. Differentiation is the same as the derivative, and it's the same as the gradient function of a curve. Now the differentiation is the same. If you may be told to get the derivative of this function here, now the derivative is just the same as the differentiation. You can be told to get the gradient function of this equation here, is just the same as the differentiation. Now the next thing we are going to discuss here, to find the derivative. Someone tells you to find the derivative. Find the derivative of an equation here, equation of s, that s is equal to 2t cubed minus 3t squared plus 4t. This is a function, and that is a function. It is long, it's a long function. Now we want to know how to differentiate that long function, that s is equal to 2t cubed minus 3t squared plus 4t. Now, to get the derivative of this function, we differentiate each and every part of this function, differentiate them differently. We differentiate each and every part, and from this point we introduce something we call ds over dt, or it is called the dy over dx. When this equation in y and x, we call it dy over dx. But when this equation is form of s and t, we call it ds over dt. Now we differentiate each and every part independently. Now here, when we differentiate this one here, we will say it is 3 times 2 t raised to power 3 minus 1. That is the first part, minus 3 times 2 t raised to power 2 minus 1. That is the second part. Then the third part is here is 1. Now I can say it is 1 times 4. 1 times 4 t raised to power 1 minus 1. Now when you differentiate here, you will find that this part dy ds over dt is equal to, that is 6t squared minus 6t. That is raised to power 1. Now I can say minus 6t. Then here 1 times that is 4 plus, yes, plus 4. Then t here is 1 minus 1, that means 0. But any number raised to power 0 is always 1. Now that means the value of t here is 1. Now 4 times 1 is 4. Now that is what we call the derivative of that question. The derivative of that equation. Then the next part we are going to discuss is the gradient function and gradients of a curve. Gradient function and gradients of a curve. Gradient functions and gradients of a curve. Gradient functions and gradients of a curve. Gradient functions and gradient of a curve. What is a curve? Now, a curve is something which looks like this. You may have a curve looking like this. A curve. Now, if you look at this thing, getting the gradient of a curve like this, the gradient keep on changing. The gradient at this point is not the same as the gradient at this point. It is not the same as the gradient of this point. Now, to get the gradient, we always get the gradient of a curve at a given point. For example, if I have this point to be 1, 2, we get the gradient of a curve at a given point. Now, to get this gradient of a curve at this point, we need to find something called the gradient function. Now, the gradient function, if you find the gradient function and then you introduce, you put the point, the x coordinate of the point, to the function that you found, you will get the gradient of that curve at that particular point. Now, gradient function, just like I said, that the differentiation of the derivative, the differentiation is always the same as the gradient function. Now, to get the gradient function of a curve, you may be given original function of the curve. For example, you are given original function of the curve. You may be given the original function of the curve, like the original function of the curve. For example, an example I have here, that find the gradient of given curve. Find the gradient of given curve, or given curves, their curves at points stated in bracket, at points stated in brackets. The curve, first curve is y is equal to x raised to power 4 minus 3x squared. The point is 1, 4. The point is 1, 4. Now, to get the gradient, we need to get the gradient function, which is the dy over dx. And the gradient function is always equal to the differentiation. Now, to differentiate this is 4x cubed. You understand that because I've taken this multiplied by the coefficients, which is 1 at this point, then 4 minus 1, it brings 4x cubed minus 6x. Now, this is the gradient function. Now to get the gradient now, we take the point of x coordinate here, and we replace, we just put the value of x coordinate to the equation, then we get the gradient. That now the gradient now can be 4 into x cubed, that is 1 cubed plus 6 times 1. What is that? 4, that is 4, because 1 cubed is 1 times 4, that is 4 plus 6. Now I find the gradient at that point of that curve is 10. Another example is that find the gradient of this stated point of the curve y is equal to x raised to power 5 minus 7x plus 3. Now we want to find this gradient. I find the gradient function dy over dx, which is equal to 5x raised to power 4 minus 7, but this one here becomes nothing, it becomes 0. How? It becomes 0 here. Now this one is becomes 0 now. This is as no x. Now we cannot differentiate it. Now it is, we just leave it that way. A constant, we don't differentiate, we leave it that way. Now the gradient function is this. This is my gradient function. Now I want to find the gradient of that curve at a point, at the point 0, 3. At the point 0, 3. At the point 0, 3. What do? I replace the value of x into the equation. I substitute the value of x into the equation. I find that is 5 into x is 0. That is 0 raised to power 4 minus 7. All of this is 0. Then minus 7. I find my gradient to be negative 7. Now that is how we get the gradient of a curve at a point. You've now seen how we got this. First of all, we found the gradient function, which is this. Then we take the value of x2, replace it into we substitute into gradient function to get the gradient of the curve. Now the next thing we are going to discuss here, another question under the gradient, that at what point is the gradient of the curve? At what point is the gradient of the curve y is equal to x squared minus 3x plus 2 is 9. Now at what point? We want to find the point. We want to find this point where the gradient of this curve here, is equal to 9. We want to find that point. Now the first thing we need to do is to find what we call the y over the x, which is the gradient function of that curve. Now the gradient function of this curve is 2x plus 3. 2x plus 3. Now I have this 2x plus 3 is equal to 9, because when we place the value of x here, we'll get 9. Now we want to find that value of x at this point. Now I take that to the other side, that's 2x. What? Minus 3. I'll say that. Sorry. This is minus 3 here. That is 2x minus 3. When I differentiate this, that is 2x minus 3. Now to find that value of x there, I'll say 2x, I take that to the other side, is equal to 9 plus 3. What is that? 2x is equal to 12. I divide by 2. I find that x is equal to 6. Now at that point, I've only found the value of what? Of x at that point, where the value of x is 6. Now where the point x, where the x coordinate is 6, we have the gradient of 9. But we want the point. The point is in form of x, y. Now we have to find the value of y, because we found the value of x, we have to find the value of y. But the original equation here is telling you that y is equal to x squared minus 3x plus 2. Now we have to replace the value of x we found to get the value of y at this point. Now what is my value of y? Y is equal to x squared. What is x squared? X is 6. Now x squared is 36 plus minus 3x. The 3x is 18 minus 18 plus 2. Now 36 plus 2, 36 minus 18, that is 18, plus 2, that is 20. Now I can say the value of x and y at that point, x, the coordinate of that point is 6, 20. That is the coordinate at the point, that is the point where the gradient of that curve is 9. Now that one is well discussed. Now that one is well discussed. 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 Now, the next thing we are going to talk about is the equation. Equation of the tangent. Equation of the tangent and the normal. And the normal. And the normal to the curve. Equation of the tangent and the normal to the curve at a point. Equation of the normal and the tangent to the curve at a point. Equation of the normal and the tangent to the curve at a point. That's what we want to discuss next. Now, let's assume we have a curve, that this is our curve. Let me just assume that this is my curve at this point. This is my curve, this is a curve. Now, the tangent to this curve is any line, a line drawn at any point, which touches this curve at only one point. Now, this is what we call the tangent. It can be drawn at any point or at this point, but touches this curve just at one point. Now, those are what we call the tangent. Now, look at this is the tangent and a normal. A normal is a line which is making 90 degrees. Now, this is the normal to that curve. It is the normal to that curve, and this is the tangent to that curve. What is the relationship here? You'll find that the normal and the tangent, they make an angle of 90 degrees. They intersect at right angle, and they are straight line, all of them. Now here, to get these equations, we'll use the rules of the straight line, or the gradients of the straight line, or the rules of the straight lines. That is what we are going to use here, because if you look at this normal, it makes 90 degrees with the tangent. But there is also another thing that one need to know here, that the gradient of this tangent, the gradient of the tangent is always equal to gradient of the tangent is equal to the gradient of the curve, at the point. Is equal to the gradient of the curve at the point. Now, when this tangent passes at a point, for example, the point of 2, 1, then we get this gradient, and we are given the equation of the curve to be y is equal to even x squared. To be y is equal to x squared. Now, we will find the gradient of this. We'll find the gradient of the curve at point 2, 1. Then this gradient that we found at point 2, 1 is equal to the gradient of the tangent. Is equal to the gradient of the tangent. Now, having discussed that we will use an example. We'll use an example that find the equation of the tangent to the curve. Y is equal to find the equation of the tangent to the curve y is equal to x cubed plus 2x plus 1 at a point at point 1,4. I have that question that I find the equation of the tangent to the curve y is equal to x cubed plus 2x plus 1 at a point 1,4. Now, first of all, I have to find the gradient function of the curve. Gradient function we say at dy over dx at that point. Dy over dx will be 3x squared plus 2. 3x squared plus 2. If you use the rule that I said, you will get this is the gradient function. Then we find that gradient, that is the gradient function. Now let us find that gradient of that curve. Let's find that gradient of that curve to be, we replace the value, we substitute the value of x here into the equation. We find that is 3 into 1 squared plus 2. Now that is just 3 plus 2. I find the gradient at that point is 5. I find the gradient at that point is 5. Now, the relationship is that the gradient of this curve at a point, now it is like this point here is 1,4, and I found the gradient of this curve at this point to be 5. Now I want to find the equation of the tangent, but the equation of the tangent also passes this point. And the equation and the gradient of the tangent at this point is equal to the gradient of the curve at the same point. Now to get the equation, now I have this tangent. Now because the gradient is the same, it has a gradient m over 5. Then it has passed one of the point, which is 1,4. Now to get the equation, I choose another point and mark it xy. Then I'll need to get the equation. Now, if you look here, it is a straight line. That means the equation we are going to get must be in form of y is equal to mx plus c as the equation of the linear equation, not the equation of a straight line. What is that? We will work as if we are getting the gradient, but we have the gradient having this point and this point. But you know the gradient is always change of y over change of x. Now that means it is final y, which is y minus 4 over x minus 1 is equal to 5. This 5 I can put it over 1, then I cross multiply the equation, then I cross multiply the equation, when I cross multiply it, I'll say that is y minus 4 is equal to 5 into x minus 1. Let me expand that. Y minus 4 is equal to 5x minus 5. Then I need y at this point, because the equation must be in form of y is equal to mx plus c. I need y at this point. That means this one takes the other side. Y is equal to this one going the other side, 5x minus 5 plus 4. Now y is equal to 5x minus 1 as the equation. That is now the equation of that tangent to that curve at point 1, 4. Then we the question continues as in I found the equation of the normal. Now let me now find the equation of the tangent. as in the equation is continuing, at this point, and the equation of the normal at the same point. Now the equation of the normal. Now I need to find the equation of two lines. The tangent, I found the tangent, which is this. The equation is this. Then I need the equation of this normal. Now the tangent line and the normals, they are perpendicular to each other. And you know that the gradient when you have m1, m2 is equal to -1, as they are perpendicular. They mean the normal and the tangent are perpendicular to each other, is equal to -1. Now, having the first gradient as 5, then 5m2 must give me -1. Now that means m2 is equal to -1 over 5. Now the gradient of the normal here is -1 over 5. But I have it also passes at this point. The normal also passes at the same point, which is 1, 4. It also passes at the same point, which is 1, 4. I have this point. Then it passes to another point, which can be said to be in coordinate of x, y. It passes to another point which can be said to be in coordinate of x, y. Then I have its gradient. To be -1 over 5. Then I need that equation. The gradient, to get this gradient, I'll say that y, final y minus the initial y, that is y minus 4. Then x divided by x, final x minus initial x, that is x minus 1, is equal to -1 over 5. Then I cross multiply that one again. I find that is 5 into y minus 4 is equal to -x, plus 1, How does that one come? I've multiplied this times this, that is -x, then -1 times -1, that is plus 1. Now expanding this, I find that is 5y. Expanding that, I find that is 5y minus 20 is equal to -x plus 1. This goes the other side. 5y is equal to -x minus plus this minus 20 going the other side, that is plus 21. When I add those, then I'll divide this one by 5. To get the equation in form of y is equal to mx plus c. But there is no problem if you leave it at this point. But just to have the equation in form of y is equal to mx plus c, I'll say I divide this one this way. I find that y is equal to -x plus 21 over 5. Now that is an equation of that tangent. To the curve. Now I've discussed the equation of the tangent to the curve, and the main point you have to know is that the gradient of the tangent to the curve at a point is the same to the gradient of the curve at the same point. Then the gradient of the normal, when you multiply the gradient of the tangent, it gives you -1. Now there's just the relationship in the equation of a straight line where the gradient where we get the gradient of the normal and the gradient of the parallel. Now the next part I'm going to talk about is stationary points. Stationary points of the curve. 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 That is the next part. Stationary points of the curve. stationary points of the curve. These stationary points are always can be said to be the turning point of the curve, and in the turning point of a curve, at a turning point, the point at which the curve is turning, always the gradient function is equal to 0. Always the gradient function is equal to 0 at the turning point. Now, for example, okay, in the stationary points we have three kinds of stationary points. We have what we call the maximum point, the maximum stationary point. We have the minimum stationary point. Then we have the point of inflection, We have the point of inflection. How do the maximum turning point looks like? The maximum turning points looks like this. It's something which looks like this, or when you draw a curve, it looks like this. Now, how will we know that the turning point of a curve is maximum? If you look at this part of this line, the gradient of this part here is always positive. Now that means when you take the value of x and put into the gradient function and you find that this part here is positive, then this stationary point here, at this point here, the gradient is always 0. That straight line, this line here, the gradient is always 0. Then at this point here, when the line is moving this way, then the gradient is always negative. Now, the upper turning point or the maximum turning point of the curve has the gradient of positive, 0, negative. Then the minimum turning point is always something which looks like this. This one here, this gradient of this point is negative, then this one is 0, then this one is positive. Now the minimum turning point has the gradient of negative followed by 0, positive. Then point of inflation are always look at the graph of the boiling graph, or the cooling curve and the heating curve. Now it may look like this, or it may look like this, the cooling curve. It may look. Now, okay, let's use this first. This is positive, 0, positive, or it negative, 0, negative, negative, 0, negative. Now, all those points are called the points of inflation. When it's come from positive, it goes to 0, then goes to positive. That is a point of inflation. It becomes negative, 0, then goes to negative. That is a point of inflation. Now, we want to find these points of inflation. I say now the turning point of a curve, the gradient function is always equal to 0. Now you can find the turning point of a curve when the gradient function you are given to be 0. Now we have an example. We have an example here. Identify the stationary point of the curve y is equal to that one. For each point, determine whether it is maximum, minimum, or the point of inflation. You have identify the stationary points. The stationary points of the curve y is equal to x cubed plus 2x plus 3x, x cubed plus 3x minus 3x, x cubed minus 3x plus 2, and for each point determine whether it is maximum, determine whether it is maximum, minimum, or point of inflection, or point of inflection. Determine whether it is maximum, minimum, or point of inflection. I have that curve. And I have to find the turning points of that curve or the stationary point of that curve. Then I determine whether it is maximum, minimum, or point of inflection. For those points I'm going to find. Now, to know, first of all, I need to get the dy dx of the curve. I'll find that of the curve y is equal to x cubed minus 3x plus 2. That is 3x squared minus 3. Now that is my gradient function. Now from this gradient function here, I must equate it to 0. Now at the stationary point, the dx dy is equal to 0. Now I equate that one to 0. Now I find that 3x squared minus 3 is equal to 0. I take this one the other side. 3x squared is equal to 3x squared is equal to 3. 3x squared is equal to 3. What do? I can divide this one by 3 both sides to remain with x squared is equal to 1. Now what is x? X is equal to plus or minus, so I mean 1 or minus 1. I have 2 points like that. 1 or minus 1. Because when you square 1, you will get 1. When you square negative 1, you must get what? 1. Now the point x can be 1, x is equal to 1 or negative 1. Those are 2 points. Now I must know this point here when x is negative 1 and when x is negative 1, the value of y, because they need the point of a turning point, and the turning point must be in coordinate form that y, x. Now I need to get this point here. Now to get the value of y when x is equal to 1, I go to the original equation here, that y is equal to x cubed, but x is 1, that is 1 cubed minus 3x minus 3 times 1 plus 2. Now x cubed is 1 minus, that is 3, plus 2. 1 plus 2, that is 3. Then this is now becoming 0. The first point is 0. Now I'll say the first turning point is 1, 0. Then the next turning point, when x is negative 1, I'll put it here, that is negative 1 cubed minus 3 into negative 1 plus 2. Now that is negative 1. That is 3, I think that is plus 3 plus 2. That is 5. 5 minus 1, that is 4. Now I'll find the next point is negative 1, 4. Having those 2 points, these are the 2 turning points of this curve. 2 turning points, all the 2 stationary points of that curve. Now I need to find again, I need to determine whether these 2 points are the point of inflation, maximum point, or the minimum point. Now to determine that, I will have a table. And this table must be the 3 things: the gradient, the value of x, the gradient, and the representation of that gradient. Now, if you look here, the value of x at this point, now I have to deal with the 2 turning points. Now the value of x at this point is 1. And at this 1, the gradient are found to be 0. Now that is the stationary point. Now I'll draw a table. I'll just draw this table here. I'll draw a table, and this the table of 3 columns. This is x, and this is my gradient, and this is the diagrammatical representation. I want to see whether it is maximum, minimum. But at this point here, at the turning point there, hapo katikati, we'll find that the gradient is 0 when the value of x is 1. The gradient I find to be 0. Then the representation of this part is a straight line. Then I'll move backward. From 1, I go to 0. Then from 1 here, I go to 2. Now I have to get the gradient at this point when the x is 0. But the gradient function is here. Now the gradient function is 3x squared minus 3. Now I'll find when I replace this one here, this 0, which is the value of x, into this gradient function, I'll find that the gradient here is negative 3. Then when I replace this one here in this function, that is 3x squared, I mean that is 12 minus 3, that I find this one to be 9. Now this is a negative gradient. A negative gradient is a line which looks like this. Then a positive gradient is a line which looks like this. If you look at this point, the way it behaves, it is a point which behaves like this. It's a point which looks like this, or which this is the minimum turning point. That is the nature of the first turning point. Then the next turning point, where I deal with it when the value of x is negative 1. Now I have x, then having this part to be negative 1. Then when I move to this point here, I'll have negative 2, and this one will be 0. Now at this negative 1, the gradient here I've found it to be 0. Then I want to find the gradient when the x is now negative 2. I come and replace this value here at this point, that is 3 into negative 2 squared minus 3. That's negative 2 squared, that is 4. 4 times 3 is 12 minus 3. I find that one to be 9. Then when this one is 0, I find that one to be negative 3. Now representation, this one is a positive gradient, 0 gradient, then a negative gradient. Now this turning point looks like this, of which this is the maximum. Now those are 2 turning points of that curve and their nature. Because the question was asking, identify the stationary points. The stationary points are this, and this are the stationary points. Then they are saying to determine whether it is the maximum, minimum, or the point of inflation. I found that the first stationary point is minimum, then the next stationary point is maximum. Now that is how we find those stationary points, and we find their nature. Now those are how we find the stationary point, and we find their nature. Now the next part is application of differentiation in calculation of velocity and acceleration. Application of differentiation in calculation of velocity, and acceleration. In calculation of velocity and acceleration. Now here we'll have an equation. Mostly we'll have an equation of S. S is always the displacement or the distance covered by a moving body. Then I'll have velocity here to be, V to represent the velocity of a moving particle or a moving body. Then velocity or the speed, it can be called the speed of a moving particle. Then I'll have A to represent the acceleration. acceleration of the particle or of a moving body. Now, what we need to know here, when you are given an equation which an S equation will have an S equation. To get the velocity equation from an S equation, we will differentiate the S equation to get the velocity equation, then we differentiate the velocity equation to get the acceleration equation. Now, that is how it is applied to get that given S equation, we differentiate S equation to get the velocity equation, then you can differentiate the velocity equation to get acceleration equation. That means, because S will be given in terms of t. I mean the function S in terms of t. Now, to get this, the velocity will be ds over dt, and to get the acceleration, velocity is equal to ds over dt, then acceleration is equal to dv over dt. We get the acceleration. Now, from that, we are going to use an example there. We are going to use the past KCSE question, that was KCSE 2018 number 19. It was saying the distance covered by a moving particle, the distance covered by a moving particle is given by S is equal to t cubed minus 15t squared plus 63t minus 10. Then part A of the question, here is find part A, the distance covered when t is equal to 2, distance when t is equal to 2, B, distance in the 30 seconds, in the third second, then C, the time when the particle is at rest, 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 then D, acceleration when t, D, acceleration when t is equal to 5, when t is equal to 5. That is 2018 question paper 1 number 19. Now I want to get the solutions. We are given the S equation. Here. This is the S equation, that S is equal to t cubed. I'm going to use this equation. S is equal to t cubed minus 15t squared plus 63t minus 10. Now we want to find the distance S. In fact, the distance is S. This is S, the distance covered. Now we want to find S when t is equal to 2. Now to find S when t is equal to 2, we just substitute the value of t in this equation to get S when t is equal to 2. Now S is equal to 2 into, S is equal to 2 cubed when t is equal to 2. That is 2 cubed minus 15 into 2 squared plus 63 times 2 minus minus 10. Minus 10. Now what is this? That is 8. 2 cubed is 8 minus 60. That is 2 squared is 4 times 15. That is minus 60 plus 126. 126 minus 10. Minus 10. Then let me add this and this. 126 plus. Okay, I can just get the equation direct. 8 minus 60 plus 126 minus 10. Now I find that the distance covered here is 64 meters. The distance covered there is 64 meters. Then the next thing is that distance covered in the third second. Now to give the distance covered in the third second is like you get the distance over when t is equal to 3 minus when t is equal to 2. That is the distance covered in the third second. That is the third second only. Remember that this thing is not moving at a constant velocity. It is accelerating as it goes. Now, the distance that it will cover in the third second, when t is equal to 3 and when t is equal to 2 are different. Now, the distance covered at the third second is when t is equal to 3 minus when t is equal to 2. But when t is equal to 2, we found it to be here, 64. Now we'll find the distance when t is equal to 3. Now we'll just substitute the value here that when t is equal to 3, find that distance there to be t cubed, that is 3 cubed minus 15 into 3 squared plus 63 times 3 minus 10. That is 27. 15 by 9 minus 15 by 9. 15 by 9. I find minus 135. Minus 135 plus 63 by 3. 63 by 3 plus 189 minus 10. That answer 27 minus 135 plus 189 minus 10. I find this one to be 71. But in the third second, now it is when t is equal to 3, which I found here, minus when t is equal to 64. Now I subtract 64 from that 71. I find the distance covered there in third second is 7 meters. Is 7 meters. That is the distance covered and in the third second. Then the next part of the question, they're asking the time when the particle is at rest. Time when the particle is at rest. Time when the particle is at rest. When the particle is at rest. What happens when the particle is at rest? The velocity, when the particle is at rest, the particle is not moving. That means the velocity is equal to 0. The velocity of that particle is equal to 0. Now we will find the velocity question, because this time the velocity of the particle is equal to 0. Now we will find the velocity of this equation. We will find the velocity equation. When the velocity equation is equal to ds over dt. And what is ds over dt? When we differentiate this equation, we find that it is 3t squared minus 30 t plus 63. When we differentiate that, we get that one there. That is now my velocity what? Velocity question here. Now this one here is equal to 0 at the point where at the point when the particle is at what? At rest. Now we will find the value of t here. And if you look at this is a quadratic equation. Now we have to solve the quadratic question here. Now I can take this one to the other side. I can take this one to the other side, or what I can do, okay, I can take this one to the other side. I'll have 3t squared minus 30t is equal to 63. Let me divide by 3 throughout. Negative. Good. Negative. Oh, sorry, this is negative 63. Dividing by 3 throughout, I find this. I'll have that is t squared minus 10t is equal to 21. Is equal to negative 21. Then this one here, I can factor out t. Now I can say when I factor out t, that is t into t minus 10 is equal to negative 21. Is equal to negative 21. Now I can say t is equal to negative 21, or I have t minus 10 is equal to negative 21. T minus 10 is equal to negative 21. Now I have t is equal to negative 21 plus 10. Now I found that t is equal to negative 11. Now I have the values of t, two values of t there. T being negative 21 and t being negative 11. Those are the two values of t, because they want the value of t time. Now those are the two values of what? Of t. Now the next part, the acceleration when t is equal to 5. 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 Now acceleration equation is equal to dv over dt. And what is that? dv, the value of dv over the value of dv is this one here. dv is this one here. Now we get dv over dt, and I differentiate that. I found it is x. I found that is 60 minus 30. 60 minus 30. Now I want to find the acceleration when t is equal to 5. What do I get? What do I do here? I substitute the value of t with 5. Now I find that that is 60 minus 30. That is 6 times 5 minus 30. I find that to be 0 meters per second squared. This the time is in seconds. This time found here in seconds, and the acceleration is 0 meters per second square. 0 meters per second square. 0 meters per second square. And that is the end of that question. And that is the end of that question. That is the end of that question. That is the end of that question. Now the next part we are going to discuss is what we call the maxima. Maxima and minima. And I'm going to use just one example. Maxima and minimum. This is where we find the maximum and minimum areas, volumes, and everything. Now, for example, I have an example here. A farmer had 100 meters of wire. farmer had 100 meters of wire. 100 meters of wire mesh to fence a rectangular piece of land. To fence a rectangular piece of land. A rectangular piece of land. Find the maximum area it can fence. Find the maximum area. Find the maximum area it can fence. Now, a farmer has 100 meters of wire. A farmer has 100 meters of wire to fence a rectangular piece of land. Now, I have this rectangular piece of land. Then a farmer has 100 meters of wire, meaning the distance all around this one here should be 100 meters. But let me just mark that part to be x. Let me just mark that part to be x. Then this one here will be 50 minus x. How does that one comes to be 50 minus x? You find that this is x, this one here is x, this one here is x, and this one is also x. Now to get these distances here, this one and this one here remaining here, can be 100 minus 2x, but I only need the width. Now I need only one width, that I divide it by 2. I'll find that is 50 minus x. Now I have that one to be 50 minus x. Now you know that area is equal to length times width. Now area here, I multiply that, area is equal to x into 50 minus x. Then area here is equal to x, that is 50x minus x squared. And the maximum, at the maximum, this area must be equal to 0. 50. This is 50x. So this is 50x. 50x. At maximum, that area must be equal to 0. At maximum. At maximum, the derivative of the area, or the function, the derivative of this area, the area function must be equal to 0. Now what do we get? We get the derivative of this. I find that that is 50 minus 2x is equal to 0. Is equal to 0. Now I need to find the value of x at this point. I can take this one to the, I can take this one the other side, or I can take this one the other side. I find that 50 is equal to 2x. Now I divide by 2. I divide by 2. I divide by 2. I divide by 2. Divide by 2. I divide by 2. Oh, the question is to find the maximum. The maximum width. The question is to find the maximum width, not the maximum area. Now this goes with this, then this goes with that. That goes with this. This one goes 25. Now you will find that x is equal to 25. X is equal to 25, and that is the length here. X is equal to 25. X is equal to 25, and that is x is equal to 25. Now I need the maximum area. Here is maximum area. Sorry, here is maximum area. Now I can get the maximum area, the maximum width, or the maximum length. There is no problem. But x is equal to 25. That means here is 25 here. Then the width was given to be 50 minus x. 50 minus x, which is also 25. Now, what do we get here? To get the area is equal to this times this. That is 25 times 25. What is that? 265 square meters. 265 square meters. Is it 265? 25 by 25. 625, sorry. This 625 square meters. That is the maximum area the wire can fence. Then there is an example, the last example, which is under the turning points that I'm going to discuss. This was also in 2018 ACC number 24. 2018 ACC number 24. 2018 KCSE number 24. It is saying the equation of a curve is given by y is equal to a third x cubed minus 4x plus a third x cubed minus 4x plus 5 that is, then we are told to determine number 1 part A. We are told to determine the value of y when x is equal to 3. Then part B, we are told get the gradient of the curve when x is equal to 3. Then the next part we are told to get the turning point of the curve and their nature. See, turning point of the curve and their nature. Turning points of the curve and their nature. Turning point of the curve and their nature. Turning points of the curve and their nature. And that's what we want to discuss as we mark the end of this topic. That's what we want to discuss as we mark the end of this topic. That is what we want to discuss as we mark the end of this point, of this topic. The equation. Now, the value of y when x is equal to 3. Now, I'll just substitute this value here. Now, we say that it is a third into x cubed, that is 3 into 3 cubed minus 4 into 3 plus 5. Now what is that? That is a third into 9, a third into 27, that is 9 minus 12 plus 5. That is 14. That is 2. Now the value of y is equal to 2 at that point. Then the gradient of the curve at x is equal to 3. The gradient of the curve, to get the gradient of the curve, first to get the gradient function. You get the gradient function, which is equal to dy over dx of that function, which it is x squared when I differentiate the function x squared minus 4. X squared minus 4 when I differentiate that function, x squared minus 4. Now, to get the gradient, I substitute the value of x into that. When x is equal to 3, that is 3 squared minus 4. That is 9 minus 4, which is equal to 5. Then The last part. The last part can be, you can try the last part alone because the time is not on our side. The last part, you can just try it alone in 22. And that is the end of our topic today.